So we've been working with strings from the start of class, especially with file paths and then with attributes. Also when we go to print things out. But this week we're really going to delve into details with managing strings. I'm here on the 318 website going to go into strings and writing them to files. This is a big area in natural resources, is being able not only to write out text files or files with strings in them, but also being able to read files, reformat them, and write them back out again. That's probably like a third of what I do in Python or more. Okay, so first thing to know is that strings are made up of characters. So characters are each 1 byte or 8 bits. Each one of the things that you see here, that's a character. That C, that H is a character. That's a capital C, that's different from a small c. That P is a character. Even the space is a character. The 1 is a character. The dot is a character. So all the text you see is made up of individual characters. These double quotes are a character. And each one of these has a number. Now, for the English and European languages, we can do it in 1 byte. For other languages like Chinese, which has 50,000 characters, we use Unicode, which has 2 byte character codes. We can only have 256 characters in 1 byte, so we have to go to 2 bytes to be able to represent Chinese and all the languages, all the characters that are used on the entire planet, which is pretty cool. Okay, so let's go ahead and take a look at some code and what happens. Please read through this, but I'm going to jump into code. Whoops, let's do a new one. Okay, so fairly simple piece of code here. And I'm going to go ahead and make a folder for lab 06 and just save this out as learning 1. Okay, wait, where'd wing go? There it is. All right, so what you can see is that if I run this code with a breakpoint, and we go down here into stack data, you'll see that that created last name, and here it looks like a string. Now you can actually double click on and edit it. We don't usually do that, but if we want to go in and pull out just 1 character, we can do that. And we do that the same way we access other arrays in Python, with a starting bracket, an index, and then an ending bracket. Okay, and that'll give us the first one because it starts at 0, and you can see here we've got a D. Now that is still keeping that as a string, but know that it's a number. And then we can go ahead and print that out. So this is how we get to 1 character within a string. You can use array indexes to do that. That allows us to slice and dice these up. Now, there are some special characters you need to know about. Remember, with file paths, we couldn't put in just a slash or a backslash because that indicated a special character was coming. Well, these are some of those special characters. Tab is /t. Carriage return, which you don't really use anymore. It's actually an old term from typewriter days, but line feed we will use a lot. And line feed is what we put into text files to go to the next line. Now, one of the issues is on Windows, officially, you're supposed to use a carriage return and then a line feed to go to the next line. On Mac and Unix, it's just /r. However, most of the computers are now adapting, and if they see anything that's a end of line character, they'll go to the next line. We'll talk more about what that means when we get into writing files. Okay, so formatting strings. Formatting strings is kind of complicated in Python because it changed between the different versions of Python. You've already seen that if you just print something out that's a string or a series of strings, you can just concatenate them together. Okay, and then if you have something that's a string and you want to print out a number after it, you use format, and that will convert the number to a string. In reality, format will convert just about anything to a string. So when in doubt, do format, and then you can concatenate strings together. And off we go. So, and you can also do this outside of the print statement. You can concatenate strings together. Just remember, we're concatenating, we're not adding. Those are 2 different things, but they both use plus, so that can be a little bit confusing. There's lots you can do. Formatting, I'll go ahead and do this one really quickly. So we run this, you'll notice John Doe is not really what we want. I want to put a space in there. We can do that. Okay, so pretty easy to format with just strings. Where it gets a little more complicated is we want to have control over the number of digits. And there are different formats to do this in Python. Some of you are already using different things than I do, and that's fine. As long as it works with Python 3.8, I don't care. But this is the one that I tend to teach folks because I think this is the easiest to learn and use. And so you can see that what happens here is we give it the number we want to convert to a string, and then there's a comma, so this is another parameter, and the dot indicates the decimal point, and then we indicate how many digits we want to have after the decimal. Cool? So I think that's the easiest one, and here's some examples of how you can control that. And this wasn't important really when we're printing to the console, but as soon as we start printing to file, we need to have much greater control over things. Now notice here we said .2, so it's going to go ahead and do 2 digits, but it has to go to scientific notation. Here we've done 6. Here we've done 16, but notice you're only seeing 9, okay, because we haven't told it to sign extend, or to extend it with other characters. In other words, with this notation, it's only going to do 16 if the characters are there. Okay, now we can fix that by using 2F. I don't know why the notation is like this. It's not my fault, but it's what the original programmers who created Python came up with. So if you do a 2F, that's going to fix it to 2 digits after the decimal. So different than the number of characters overall, that's going to give you the number of digits after the decimal. Okay, if you want to control the number of digits before the decimal, so you can make a really nice looking outline, notice what it'll do is it will pad it here. I think that's what it's doing. And the best thing to do with all of this is to play with it. Okay, yeah, I think that's giving 10 overall, 2 after the decimal. Okay, yeah, total number of digits. Really good to go through these notes. And then you can get much more complicated with format. There's documentation on the Python website and lots on the web. But that's where I'm going to leave it because that's really everything that we need except how to format coordinates. And one of the reasons I do this is because it gets a little bit strange. And it also varies with the GIS package. In other words, if you put things into a text file, it may be different than putting them into attributes for ARC. So this is how we get things like the degree symbol here. Okay, so what I've got here is, notice that I've said go ahead and do up to 7 digits after the decimal. What does the 0 do? Okay, I'm not sure. But let's play with it. Okay, now this is the part that's probably got you thrown for a bit. This is how you put a degree symbol in. Yeah, it looks really weird, but what this is doing is this is saying backslash, so a special character is coming. X indicates hexadecimal. And then this is actually the hexadecimal or base 16 number for the degree symbol. Yes, this is weird and strange, but this is what you have to do to get a degree symbol. The good thing is, all you have to do is remember that, write it down somewhere where it's easy to get to, and just stick it in wherever you want a degree symbol in a string. Now, like I said, it may vary a little bit. If you put something up on the web, it's different notation than it is for this. This is the standard ASCII notation, but you can see that it works. Cool. Okay. The other one to know is that sometimes it gets really interesting when you want to put double quotes or single quotes like we've done here. Okay, so in that case, if we're going to break this up and we want to print out a coordinate string that has degrees, minutes, and seconds in it, okay, in other words, you might want to print out 40 degrees. And then you need to put out the degree symbol, which means we need a backslash x b0. Now I do this a piece at a time to make sure I'm doing this correctly. See, got an error. Oh, I think I used an O instead of a 0. Yep, wrong circle thingy. There we go. And now if I want to add minutes onto that, that would be like 12 minutes, which would be a double quote. Now the problem is if I put in a double quote, it's going to terminate my string. So I need to do slash double quote. So the double quote goes into the string, and then a double quote to terminate the string. Okay, oops, probably should put a space in there. There we go, so it's looking nice. Now, when you look at someone's code like this, you might go, what the heck? I mean, it just looks strange, right? Because you've got two double quotes together, and then you've got this backslash. And you need to think about the code from the standpoint is that here, this double quote takes us into a string. And then this backslash double quote puts a double quote into the string. And then this double quote terminates the string. So that's sort of how I always think about it. And then we can go space and have a single quote. And because we're using double quotes outside the string, we can use a single quote inside the string without having to backslash it. So there's how you get, oh, and I reversed it. As you can see, I tend to do things a little bit at a time and then go back and fix things. It's also early in the morning. So there we go. That's better. All right, degrees, minutes, and seconds. Yay! And trust me, that's about as complicated as you're ever going to see when you're doing geospatial string processing. So don't have to worry about this for now, but keep it on hand for later.